Assalamu alaikum everyone. In this video we will have a quick revision of organic chemistry. So what is organic chemistry? Organic chemistry is the study of hydrocarbons and the derivatives, and carbon belongs to group 4, so it makes 4 bonds. You need to know what is homologous series. Homologous series have 5 properties. You need to remember this because the definition of homologous series usually come in exam and sometimes questions in MCQ related to homologous series also comes. So there are 5 properties of homologous series that you need to remember. Number 1, homologous series is a group of compounds that have similar chemical properties. They have same general formula. They have same functional group, a regular trend in physical properties, and the compounds differ by CH2. So these are the 5 properties that you need to memorize for homologous series because sometimes this definition comes in P2 and sometimes uh, this the these properties are asked in P1 in MCQs. So we have 5 components of organic chemistry. Number 1 is alkane, then alkene, then alcohol, then carboxylic acid, and then esters. So in this video, as it is a quick revision of organic chemistry, so we will discuss formulas, like how to namings of alkane and alkene, alcohol, carboxylic acid, and esters, and the formulas, the general formula. So let's begin. Before this, you need to know what is functional group. Functional group, a group of atom or a group of atom which gives characteristic properties to a compound. So functional group definition also comes for 1 mark in P2. Then let's move towards alkenes. What are alkenes? Alkenes are saturated hydrocarbons. Now, what are saturated hydrocarbons? So alkenes are saturated hydrocarbons. I'm just writing short form for saturated. And saturated hydrocarbons are those in which no addition is possible, no adding possible. And along with this, you should know that alkenes make single carbon bonds. And the general formula for alkene is CnH2n plus 2. Then let's come towards alkene. Alkene ends with ene, alkene. And however, alkene ends with ane, alkene. To identify alkene and alkene, you have to remember that the spelling is same for alkene and alkene, but there is a difference in this A and D. After K in alkene, there is A, and after K in alkene, there is E. Alkenes end with ene, and alkane end with ane. So alkenes are unsaturated. Unsaturated means addition is possible, carbon double bonds are present. So alkene have at least 1 carbon double bond. If the compound have 1 carbon double bond, so it is alkene. Let me give you a few examples to identify alkane and alkene. So here you can see 1, 2, 3 carbons, and this compound contains 3 carbons, so this is propane. How you identify that this is propane? Firstly, it have 3 carbons, and secondly, it have no double bond, so it is propane. In previous video, I told you about prefixes from 1 to 10. They start with methane, meth, eth, prop, bute, pent. Meth means 1, eth means 2, prop means 3, bute means 4, pent means 5. Hex means 6, hept means 7, and oct means 8, 9 means non, and 10 means 10. So these are 10 prefixes which you need to remember to write the compound formula, the split formula or structure formula, or to name the compounds in organic chemistry. This was one of the example of alkane. They have no double bond, they only have carbon single bonds. Like, let's look at examples of alkene. So this I'm drawing on the screen. Now you can see a double bond here on the first carbon. So double bond on the first carbon or double bond at any carbon indicates that this is an alkene, ene alkene. It contains 1, 2, 3, 4 carbon, so it is butene. Its name is butene. Now, Uh, for naming of an alkene, you have to remember that if an alkene has 4 carbon or more atoms or more carbon than more than 4 carbons, then the number of the chain, you have to decide the number of the chain, decide the position of the double bonds, and then the number of the chain from where the double bond carbon get the smallest number. So for numbering, what you have to do is to see that at from which side, from either left or right, the carbon is getting the double bonded carbon is getting smallest number. So the bond is on first carbon, so it's from left, it's getting smallest number. It is 1, then 2, then 3, then 4. 4 carbons in total, and the double bond is at first carbon, so we can write this instead of butene like this, but 1 in. But the double bond is on the first carbon, so no need to write it like this, but1ene. But what if the double bond is at second carbon? For example, in this, the double bond, not in this, let me give you another example here, over here. What if the double bond is on second carbon? The double bond is, for example, here. On the second carbon, so you can write it but2ene. Like this, you have to name the structures. You have to start the numbering from the side where the carbon double bonded carbon is getting smallest number. Okay, I hope you understood it. Now let's move towards alcohol. So the general formula of alcohol is CnH2n, CnH2n plus 1 NOH. This OH is actually the functional group of alcohol, and the naming of the name of the alcohol ends with OL, alcohol. So it can be methanol, ethanol, butanol, propanol, pentanol, hexanol, heptanol. Let me draw the structure of methanol here. Meth means 1 carbon. So 1 carbon is here. As I told you that OH is the functional group of alcohol. So here is one O and then H. This OH, which I'm highlighting using red pen, is the functional group of alcohol. Whenever you see OH in any compound like this, which I've highlighted using the red pen, so this is an alcohol. The OH indicates that this is an alcohol. Let me draw another structure. This contains 2 carbons, so this is ethanol. Like this, ethanol, and like this, the further structures of propanol, butanol can be drawn. Let me draw one more structure to tell you that how the structure which branch of OH is instead of at terminal or last carbon, it is in between. How to name that structure? So the structure contains three carbons, so it is, one with 3 carbons, prop, and the OH is on the second carbon this time. So when the OH is on second carbon, what you have to do is write the name propane 2O. 3 carbons, propane, and then the branch of OH. This OH branch, which represents that it is an alcohol, is on the second carbon, so it would be propane 2-ol. If the structure has 4 carbons and the branch is on third carbon, so it would be butane 2-ol. Let me draw the structure too. 2, 3, 4. For example, the branch is on third carbon. I'm not drawing the other hydrogens right now. So it would be butane 3-ol, 4 carbons. Now, let me tell, now let's move towards carboxylic acids. So these carboxylic acid CnH2, the general formula for carboxylic acid is CnH2n plus 1. And now let me tell you that this n numbering of carboxylic acid will start from 0, 1, 2, and then further on, as we have, and the functional group of carboxylic acid is COOH. Let me draw this functional group somewhere here for carboxylic acid. COH. And here is the double bond of oxygen. So this is the functional group of carboxylic acid. Let's look at a few examples. The structure right now I am drawing is of methanol, methanoic acid. Sorry. So it contains 1 carbon. Here is an hydrogen. Here is an hydrogen. Here is the double bond. Here is the double bond of oxygen. Here is the single bond of oxygen, and this OH. So this is methanoic acid. When it contains 2 carbon, then an OH and double bond of oxygen. So it would be ethanoic acid. So from this, you can easily identify that this the carboxylic acid with ends. The name of the carboxylic acid ends with noic acid. Ethanoic acid, methanoic acid, propanoic acid, butanoic acid, like this. Now let's move towards esters. What are esters? So these esters react with water to form alcohol and carboxylic acid. The functional group of esters is RCOOR. This one is the functional group of esters. One thing you need to remember for esters is that whenever you write or draw the structure of esters, so in writing, the alcohol in esters end at YLEIL, and acid adds with OH. Let me show you an example over here. So I'm writing an ester. It have a double bond of oxygen and also a single bond of oxygen, and then CH2CH3. So let's name this ester, and its naming would be, when you draw the structure of an ester, the structure I have drawn right now on the screen is the structure of ester. and this starting part is acid. Now, how you recognize that it is an acid? You recognize it from this double bond and a single bond of oxygen. So the carbon with a double bond and a single bond of oxygen, and before the carbons are of the acid. This is the acidic part of the ester. And after this carbon with the double bond and single bond, after this one, there is alcohol. So this one part after double bond and single bond of oxygen, carbon is alcohol. So the name, when we name an ester, the starting of the name starts with alcohol. So let's see at the alcohol part, there are two carbons. So the two carbon alcohol is ethyl. Ethyl, as I told you previously, that the name of the alcohol end with ethyl and with Y. Ethyl propanoid. Here are three carbons. Let me highlight it. One carbon, carbon two, carbon three. Propanoid. So the name of this ester is ethyl propanoid. Let me give you another example so you can have better understanding of esters. This time I'm making this discrete formula. One, two carbons, hydrogen, 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 double bond of carbon, a double bond of oxygen, and a single bond of oxygen, and then carbon, and then hydrogen. So, now see, the structure right now I have drawn on the screen is of an ester, and the trick I have told you previously to identify the alcohol in the acidic part of the ester. This is the carbon that have oxygen double bond and single bond. So the carbon, before this carbon, the part is acid, and after this carbon, the part is alcohol. While naming this ester, the naming starts from alcohol, and alcohol ends at YL. So there is only one carbon for alcohol, so it is methyl. And there are two carbons for acid, ethanoid. So it is methyl ethanoid. The acid ends with OH and the alcohol ends with YL. Methyl ethanol. I hope you understood esters, alkane, alkene, carboxylic acid, and this was the quick revision of organic chemistry. Thank you.